Thanks everyone for joining today. I'm going to be giving kind of the Atlas perspective, although having taken a quick glance over the CMS and LHCb slides, I think that this view is going to be a little bit different and perhaps a more high-level one than some of the more detailed comparisons that other people have made. So I think the discussion section at the end will be a really useful one. So going on to slide 2, I'm going to first try and just take a few minutes or a few moments to try and maybe set the stage a little bit for how I'm thinking about the discussion that we're actually having here. So in his 2017 PyCon keynote, Jake Vanderplas gave this, one of his slides included this now iconic PyData ecosystem image that kind of showed the, these multiple different tiers of as he was talking about then, the scientific or PyData ecosystem, where you have the idea of the Python software foundation at kind of the bottom, and then as you go out to subsequent tiers, you're essentially building on top of that to make different stacks, and where the previous stacks are then building on the further out stacks are building on the ones below them. On slide 3, in a recent PyHEP topical mean update, Jim Povarsky has kind of provided a view of what that might look for the Feickert HEP ecosystem as kind of a subset of what I might more generally call the PyHEP ecosystem. And to try and break this down a little bit, trying to summarize what Jim said. Jim, please feel free to issue any corrections if I'm accidentally misspeaking here on your behalf. But on slide 4, if we kind of start at the bottom of the stack and work our way up to the top, at the 0th layer, or at the first layer, at the bottom, we have non-HEP software that is actually fundamental or that we depend on. So in this situation, that's things like Python, most of that PyData stack we just looked at. So things like NumPy and matplotlib, but then also things like Jupyter, as well as tools like Dask or Numba that provide us scaling and acceleration. And then at the second layer of the stack is our tooling, tooling that isn't fundamentally specific to high energy physics, but at the same time didn't already exist out in the PyData ecosystem already, and so was necessary to create to be able to build upon. So you have things like Boost Histogram and Awkward, IMinUE. These are different tools that, while they're critical to us on high energy physics, they're not necessarily only useful in high energy physics or high energy physics facing necessarily. And in the third tier, we then have things that really are, very HEP flavored or HEP specific, but are also like very foundational. I mean, obviously, like Uproot is building off of kind of a story that Awkward started there, as well as having things like Vector, which is actually which is Lorentz vector aware, and then Coffee as well. And then the fourth tier is then focusing on much more high energy physics specific problems. MPL HEP is, for instance, making sure that we can have kind of plotting that looks very similar to a lot of the styles that already exist in the LHC experiments. And then PyHF and cabinetry, these are focused very specifically on bin statistical models. And then the kind of the fifth tier is tooling that is very either HEP specific in terms of UI or packaged algorithms like FastJet. Okay, so with that kind of set in terms of like when I'm myself thinking of like the PyHEP ecosystem and how that kind of relates to the experiments, this is a subset of what I'm thinking of. And I say like a subset because on slide 5, these ecosystems are still growing and evolving. So these visual representations of the stack are, I think, really useful, but they're not supposed to be static or fully inclusive. I mean, for example, their IRIS-HEP, we have plenty of tools that are being built and exist. So, I mean, for example, like Service X wasn't on there, like FuncADL wasn't on there. So these are all things that are interesting tools, but not but weren't fully represented there. But I think that these visuals of these stacks are really useful exercises, especially for considering the ecosystem state and growth and the needs. So the rest of this talk is going to be hopefully more of a very high level overview of how Atlas is trying to think about some of these things in terms of adoption and also in terms of R&D efforts that are currently ongoing. But I hope that this is more kind of a catalyst for discussion later on than trying to be a fully detailed summary. Okay, so on slide 6, kind of starting down at the, yeah, so Jim also has a comment in chat that I won't fully read right now. Oh, actually, maybe I should read that. Yeah, so Jim just wanted to mention that, to show how far we've come, Service X and Coffee Casa are services. It was a diagram of tools and packages, and it wasn't his intention to leave them out. Yeah, exactly. And so, I mean, also, for these diagrams of these stacks of toolings, it's not possible to put everything in, or else it would just be logos packed next to each other with no kind of discernible views. But I still think that these representations, even if they're not fully inclusive, can be really useful. Okay, so on slide 6, kind of starting back down at that first layer, so there's been some R&D efforts that have been going on in Atlas, also somewhat jointly with the Google and Atlas working group sessions that happen, that Nikolai has performed on actually trying to look at scaling tests using of physics analyses using the new-ish data format in Atlas, PhysLite, and looking at how analyses using PhysLite might be able to try and scale out efficiently on servers that are using Dask or perhaps Ray. So I've included some links here to, for example, Nikolai gave a public talk on this at Feickert 2021. And then he's also included an Atlas internal link, but that some of this stuff can be made accessible as needed. But so far he's seen that there's been quite good scaling with this so far. And so for example, here's like a plot at the bottom that's showing scaling of PhysLite analysis out to 100,000 cores with Dask, or 100,000 tasks with Dask. That was back in October 2021, and I know he's continued to be working on the studies. On slide 7, there's also been some ongoing studies inside of Atlas in terms of just looking at trying to socialize columnar analysis in general. The columnar analysis is obviously important to the IRIS-HEP basically analysis plan in general. And so inside of the experiments, we've also been trying to think about what sort of role does columnar analysis play in some of our own frameworks. So in Atlas, there's kind of a growing working group that is looking at using columnar analysis for Atlas tools and what that story kind of looks like. Lucas is one of the people who's leading those efforts. And there's been some ongoing studies so far at trying to look at providing an awkward to XAOD interface or APIs that would then be focusing on having zero copy methods. So this is just one sort of, on the right-hand side, this is kind of a very mock diagram that has been made where you could imagine having some sort of interface going from awkward to XAOD, where you first go from awkward to to PyArrow, and then through PyArrow, you then hook into PyBind11, and through there, you then access the C++ Arrow ABI, and through that API to ABI, or through the ABI between PyArrow and C++ Arrow. And then once you're in the C++ land, then you'd be able to talk directly with XAOD. Jim had kindly come to one of our Atlas internal meetings and given some additional suggestions on how we might be able to try and simplify these approaches. I won't kind of go into them here right now, but maybe we can follow up with that in later discussion. And on slide 8, maybe starting to move up the stack a little bit more. I think it's pretty much safe to say that uproot is used in a huge variety of analyses inside of all of the experiments, including in Atlas. It's basically safe to say that like any PhD student right now in Atlas that is trying to do something with Python is going to be using uproot at some level. Definitely also for the internal working groups that are doing any form of machine learning, uproot is basically a core thing there. And then also Nikolai has continued to do some studies that is also looking at the actual feasibility of reading this PhysLite data format with uproot. And so on the right-hand side, this is a slide that I grabbed from an internal talk, but I think there's nothing that can't be shared here today. And maybe I can let Nikolai talk more in questions and also in discussions about this, but this is basically just demonstrating that while kind of naively, the time to read events from PhysLite with uproot is perhaps prohibitive. You can do a little bit of work, and you should actually be able to get efficient columnar reading of PhysLite. So this is also kind of interesting work that's going to be followed up on more. On slide 9, we also have kind of moving up the stack again. There's been some ongoing studies that have been shown both at VHEP 2021 and also at other IRIS-HEP workshops on using ServiceX and Coffee for different analysis workflows in Atlas. So at VHEP 2021, Kongan showed that he was able to use a ServiceX plus T-Rex fitter to great effect for a benchmark analysis. On the right-hand side here, I'm just showing one particular slide from his VHEP 2021 talk, where on the kind of current workflow that he had set up using just root n-tuples and T-Rex fitter. Yes, exactly, Ben. So I'll get to Ben's comment in a second. Yeah, so the left-hand side is showing with root n-tuples and T-Rex fitter, and showing basically that's his kind of benchmark standard workflow, and then ServiceX workflow that was used then showed quite a bit of speed up. I believe in this particular slide on the left-hand side where it shows the current workflow and the ServiceX workflow, these times are flipped because just from the discussion, yes, the kind of the discussion points here, we can see that ServiceX was able to in 7 minutes deliver the transform of the root n-tuples, and then it only took 2.5 minutes for T-Rex fitter to actually generate the histogram. So the ServiceX workflow was at 9.5 minutes, while the basically current workflow that he was using before that was multiple hours. And then we also see that that the actual store disk space that was needed was also significantly smaller by more than an order of magnitude. I'm sorry, I didn't mean to call you out. I just wanted to. So I apologize in chat there. I don't mean to call you out here or make you feel bad. I just wanted to make sure that everyone realized that that ServiceX was doing a great job here, not that it was actually running at quite a deficit. So Konyan has also proceeded to do some really nice ongoing studies on looking at how we can further extend this with ServiceX and Coffee, and will be shown later today in the Atlas internal session. But I think he's maybe also up for discussing what parts of this work that can be publicly discussed as well. Douglas, I'm gonna follow up on that later in the discussion because I don't actually know the answer to that. Okay, on slide 10, just kind of, again, moving further up the stack in terms of Pythonic visualization. So there's been a growing kind of social trend in Atlas, and I think probably much more broadly in HEP in the past few years, that PhD students are really interested in trying to use matplotlib to perform visualizations. And so it's kind of a natural result of that. We've kind of seen a growing or explosion of different ways for people to have visualization frameworks or libraries that try and make that easier to try and get their particular style. And so perhaps most well-known and notable is this Feickert HEP's project MPL HEP, which people on Atlas have contributed the necessary components to try and be able to make it as easy as possible to get a 95% or higher like passing Atlas style setup. But there's also additional kind of public tools that have just kind of surfaced from inside of the experiments. So there is also an Atlas MPL style library that has been developed inside of by other Atlas users that still takes advantage of the UHI protocol that was developed inside of Feickert HEP. And then there's also UHEP, which is a universal, meant to be a universal visualization framework that has been used at least for one Atlas analysis. And then also coming from the same author, there's like an Atlas Vi, and I'm sure that there's basically a laundry list more of these. But it's also been clear that some of these toolings have actually been used inside of the for additional publications. For example, I know that I've reviewed different pub notes inside of Atlas where MPL HEP plots have been shown. So for example, this simultaneous jet energy and mass calibrations with neural networks pub note, I know that used MPL HEP, and there's a few others that I can't remember off the top of my head. It's maybe worth noting, though, that despite MPL HEP's general popularity and use in the Feickert HEP stack, for example, when HIS visualization, additional dependencies pull that in as well, there hasn't been yet a kind of a clear rallying around a single visualization library. The kind of a pro of that is that's not really necessary all the time, and it's good to have kind of a bazaar of ideas. But as a con, then you also have a loss of centralized contributions and upstreaming of work to matplotlib. So for example, MPL HEP ended up upstreaming the concept of like stairs to matplotlib, which has been really useful. Okay, I know I'm running short on time, so I'll try and speed up here. We've also seen that kind of going one more up the stack into kind of end stage analysis, statistical inference, that PyHF has been cited as actually being used in Atlas in 4 papers and 2 pub notes, and I think it's being used in a few other areas. So that's been nice from an IRIS-HEP Feickert HEP side of things. That's been nice to see. And then from an Atlas side of things, it's clear that there's actually kind of an interest in using the statistical tooling that is being provided by the PyHEP ecosystem. It's also and if I can put on my PyHF developer hat for a second, I can also say that it's been really nice to receive very well designed and thoughtful contributions from Atlas contributors. So thank you everyone for PRs that have been submitted there. And then it's also been interesting to see that cabinetry is still being kind of socialized in the experiment. I don't know of any analyses that are directly using it right now. Alex might, but he has also been invited to give presentations on cabinetry into different physics subgroups. And it's been also really interesting to see the feedback from those talks and how it might also point to the need for some mental shifting from fitting frameworks that have been kind of a norm inside of Atlas, such as HISFitter, to thinking about fitting libraries which are PyHF and Cabinetry. Okay, so I'm already at time, but the good news is I'm also pretty much on my last slide. So I think kind of a summary of where we are right now in Atlas is that Atlas is interested in using the PyHEP and Feickert-HEP stack, but at the moment we're really using it the most at the beginning of things in terms of trying to actually use uproot to read and interact with different high energy physics specific file formats, and then at the very end of analyses in terms of doing statistical inference. But there's plenty of ongoing R&D efforts that are trying to deeply utilize the PyHEP and IRIS-HEP stack. So as I was mentioning, we have these studies that are looking at PhysLight and then also performing analysis workflows with ServiceX and Coffee. And I know that CMS has done kind of an analysis user survey to try and actually figure out how these tools are being used inside of the collaboration. And I think that it would be both beneficial to both Atlas and IRIS-HEP if, and we probably benefit from doing a similar thing in Atlas. And if I'll just end by kind of putting on my own personal opinion hat at the moment, which is just to say that I think that there is a lot of interest in using the PyHEP tooling, at least in terms of the PhD students that I'm talking with when I'm working on analyses. And uptake hesitancy shouldn't be viewed as any sort of lack of interest or distrust, but more just an uncertainty on how to actually integrate these tools into a current analysis workflow. And if you're a young PhD student, you might not want to try and disrupt the flow of work that you're already doing. So I think that workshops like this one are really critical for trying to socialize the tools and also show technical examples like were shown yesterday and this morning on how users can actually do this.